Okay, so we are going to talk about electrolytes next. So, what are electrolytes? Well, these are just dissolved ions. And I mean dissolved in water, to be clear. So, polar solvents can dissolve ionic compounds. So we talk about like dissolves like. We're looking for that matchup. There are ionic liquids, but they weren't really known about till the 90s. It was actually a somewhat recent discovery. But water is not an ionic substance, but it dissolves ionic compounds. You've seen it dissolve salt, and any other, like table salt, and basically any salt's an ionic compound. But you've seen it at least dissolve one. We'll leave it there. If you've seen it dissolve like Epsom salts, you've seen it dissolve two. You're ahead of the game. So, how does that happen? We'll start there. So if you've got a salt, it looks something like this. So if we got like sodium chloride, and this goes in like 3 dimensions, so I can draw it in 2. So it alternates. Positive is next to negative, is next to, positive, so on and so forth. And it will go, towards us and away from us as well. So it makes like a cube. This is what they do. So this is, our NaCl salt right here. And so this is being held together by ion-ion interactions. It's just being held by positives attracted to negative, positives attracted to negative, negatives attracted to positive. That's what ties this all together. So if you have a water, like how does this work? How does this dissolve this? These aren't like each other. What's going on? I told you like dissolves like. What's wrong with me? What kind of monster am I? Say such a thing. Well, remember that this has a net dipole, right? So there's a slightly negative region here and a slightly positive region here. So remember, this is partial negative, partial positive. So these ions, these are full pluses and full minuses. And it could be something with plus 2s and minus 2s. Like it could be an even more charged salt. Well, what happens is we don't get a one-to-one interaction here. But what happens is that waters come in, and their negative region here starts being attracted to the ion. And a large number of them team up, and they start seducing the water, or the water starts seducing the ions away from each other. Some good looking water. Alright, and so what we get is something like this. We get like our Na plus, and we get our Cl minus. Now they're floating around in water. And so this has waters that are oriented. We call this a solvation shell. And I'm not drawing nearly enough of these, by the way. Just as many as I can fit on the paper. But it can be up to 30 waters doing this. And so what we get is an ion-dipole interaction. And so lots of these partial charges add up to be even stronger than these full charges that would normally be around it. And so the negative part of the water will orient towards the positive ion, towards the cation. And the opposite will happen with the anion, with the negatively charged ion. Now it's going to be the positive side that's going to interact with the anion. And so I'm using these dots here to just show not a bond, but just an interaction. So we get lots of ion dipole interactions, and we get what's called a solvation shell. Now some ionic compounds are not water soluble, and that's because the ion-ion interactions are so strong that the water cannot seduce them apart. They are inseparable. They are eternal. If you've ever skipped a rock in water, you've seen an insoluble ionic compound. The rock didn't dissolve in the water, but it's an ionic compound. So that's kind of another distinction. So they tend not to be, rocks are not covalent, they tend to be ionic. And I'm sure, and geologists will probably come along and start stomping on me about some sort of covalent compound, but I'm not talking about diamond here. No one was skipping a diamond in a pond, okay? Generally it's some sort of carbonate mineral. And it doesn't dissolve. So there are situations where the water can't pry these apart. Now, table salt is one where this definitely happens. We can dissolve salt in there. And what you can do is get what's called a saturated solution, where you pour so much salt in, it doesn't dissolve. I was afraid for a second I might have done that with my sugar demo earlier, but it totally dissolved. Alright, and so electrolytes are just ions dissolved in water. So when you're getting Gatorade, you've got some sugar in there, so it tastes good. You've got some color, so it looks good. And then you've got some salt, so that, it has the electrolytes that plants crave. Or you, or whoever. So, when we sweat, we lose a lot of salt. And this was the height of science at University of Florida, was they realized that if they give salt to sweating people, they do better at football. And that's it. That's all they've ever accomplished. Man, I hope this doesn't blow up on the internet somehow. Terra State will hate me. Be a gator in my mailbox or something. But it's totally true. They've done nothing else. I don't know. They've probably done other stuff. But, it's a big deal when you're small. We'll give them that. You're going to sweat a lot. It's not really going to help because it's so humid. Alright. Enough about Florida. As if the world isn't beating them up enough right now. Alright. So, electrolytes, where does the name come from? So, water, if you have pure water, this does not conduct electricity. So, the old trope of throwing a toaster in a bathtub, and then the person gets electrocuted and dies or whatever. That's because the water in the bathtub is conducting electricity. But pure water does not. So what's going on? Well, once you dissolve ions in the water, it conducts electricity. So if you have water with dissolved ions, which basically all water is, unless you get something like distilled water or nanopure water or deionized water, but like any river, any lake, any groundwater, the ocean, it's all going to have dissolved ions in it. Even rainwater is going to have some ions in it. Like, you have to really work to get the ions out of the water. So this will conduct electricity. So the answer is that water insulates against electricity, but effectively all the water we ever deal with in our lives will not. It will conduct the electricity. Or it will conduct electricity. Alright. So that's where the name comes from. So it's called an electrolyte because it allows electricity to move through the water. So that's where the name comes from. Alright, so that is it for this section. Hopefully you had fun with that. So polar solvents can dissolve ionic compounds because you don't have like dissolving length, but you do have similar enough interactions. So you have some partial, say a partial positive with a full negative, or you have a partial negative with a full positive, and they can dissolve those compounds. So that's how a salt dissolves in water. And so yeah, that'll do it for this section. So it's kind of like the high end part of the videos.